I think now is a great time to talk about which solver we'd like to use, because depending on which route we go, the sourcing is going to look different. We'll check out the traditional solver, the sparse, axiom, and what the workflow might be for a SOP level pyro solver. That SOP level is the same thing as the traditional, it's just a different workflow because everything is at the SOP level. So let's take a look at that right now. Starting with the traditional pyro solver. This guy's been around for the longest, and the number one reason why you would want to use this is because it has GPU acceleration through OpenCL. That means you can use your graphics card, and that's more than what the sparse pyro solver can say right now. In the future that might change though. Who knows what Houdini 19 and future releases will do. I imagine one feature that they might get into is OpenCL or GPU acceleration for sparse solving, but at the moment of recording, that is the number one reason why you would use this solver. Also, the traditional pyro is tried and true. It's been used on a lot of productions. Many things have been smoothed out. You can really be sure that this is going to be a solid workflow that's been used on many different occasions, and perhaps that reliability matters to you. I've found that the other solvers, even though they haven't been around for very long, can be just as stable as the traditional pyro solver. But the fact that this has been a go-to for a long time and that you know it's going to work smoothly could be a plus, especially if you're a studio who really values consistency and tested tools. Also, number 3, this offers the potential for detailed customization. And so what that means is if you want to go in there and really make this pyro solver your own, you have the ability to do so. What we'll find, especially with the SOP level pyro workflows, is that it's all black box. That means you can't go in there and change what's been done to make this solver. And so having the ability to customize this is really nice, because if you want to make your own feature someday, or you want to improve what's already been done here, this gives you the blank slate to work with, so to speak. Also, dual rest fields are readily available. Again, dual rest fields are used for adding noise to your simulation after it's been simulated, and that can be a very good thing. This also has strong integration with the volume SOP and DOP import presets, which is pretty handy. Might be a nice convenient thing to have on your side. And lastly, many pipelines still use this solver because they're used to it. So even though the traditional pyro solver isn't the latest and greatest solver that's out there, the nice thing is that many pipelines still use this. If you understand this pyro solver, there's a good chance that you're going to inherit a scene from somebody else one day that uses this solver because the studios like it, because they're used to it, and it's good to at least know your way around for that reason alone. Now, what are some of the cons with the traditional pyro solver? Well, for one, if you have anything that's moving fast or has a disjointed area, meaning that there is a pyro section up on the left-hand side of the screen and maybe on the right hand, and there's a bunch of negative space in between a couple of smoke clouds, as an example, that would be a disjointed area of the simulation. And in those situations, you need to use clustering, which is basically where you have multiple bounding boxes, multiple simulations resizing along the different sections of the pyro. And this particular workflow can get really complicated. It's going to take a lot of setup time, probably some debugging, a lot of research on your end, and it's something that you want to avoid if you can. Also, the combustion model is really difficult to control. In Pyro 2, we didn't go over the traditional pyro solver with the combustion, and I did that for a very good reason. It's because this combustion model here is difficult to control. There's too many parameters. There's too many terms being used for burn, fuel, temperature, flames. It's just the combination of all these things is pretty dizzying. And even if you understand what those things do, the net effect here is that it becomes difficult to control because there's just too much going on. Also, temperature and buoyancy is arbitrary rather than exact. And this is kind of a minor con, maybe even a personal preference of mine, but it's not like you define the surrounding air in Kelvin and then you define the explosion in Kelvin, which is what happens in the real world, right? Instead, it's just a value of 1 or 2 on the buoyancy, and you have temperature just doing its thing. And so it's a little bit arbitrary in how that works, rather than based on something that you see in the real world. The smoke object for the traditional pyrosolver contains a lot of settings, which adds to it being kind of confusing at first. And along with that, this was just built with too many features in mind. In my opinion, this makes the settings and the terminology feel overwhelming and pretty cluttered, especially when it comes to the combustion of fuel and temperature. Also, this will most likely be replaced by the sparse solver over time. So, what can we say in general about the traditional pyrosolver based off of that? Well, it means this. It means that it's good for you to know your way around that, but it's not good for you to stick around with that solver and not try anything else. The future is not going towards this traditional solver right here, most likely, unless they completely change most of what it is. And so for that reason, I would not seriously consider using this as my go-to solver. Instead, I would only try to use the traditional pyrosolver if I was working with a studio or another artist who had a preference for that. And even then, I'm not sure if that would be a really good idea to do anyway, because the other solvers offer a lot more benefits than what this can give you. In the next video, let's take a look at the pros and cons for the sparse solver.